But now let's get started and generally think about the concept of graphing internal forces and bending moments. So what I want to introduce to you is how do we graph these force values and bending moment values that we actually calculated in our last lectures. So I want to start with this problem here. This problem has been seen in lecture 10, where we calculated the support reactions for A and B, and I will introduce those in a second just to remember those properly. And in lecture 13, the previous one, we actually calculated the internal forces at this location, and at this location to the left and to the right of the force. And our goal today is to actually properly graph those. So let's go ahead and first pull in the values from our previous lecture 10, where we calculated the support reactions. And one of the first ones was RAY, which we determined to be 11.43 newtons. And we also calculated the value, of course, for the horizontal support reaction, which we determined to push to the right with 43.3 Newton. And last but not least, we have support reaction B, which was determined with 23.57. And that was, of course, also in Newton. Let's remember real quick that we got the support reactions from lecture 10. So if you're really puzzled about the support reactions, please go back to lecture 10 to understand properly how you determine them, because as you already saw in the last lecture, we always need the external forces first to find the internal forces. And let's therefore talk about the internal forces that we actually calculated at this location here, to the left of the force, to the right of the force, to the left and to the right of this force. And to do that, let me first bring in the dimensions. And let's remember that the beam had dimensions of, I believe, 4 meters on the left side. And then we had 1 meter in between the two forces. And we had 2 meters at the end here. And so those are the dimensions for which we calculated the support reactions really at this location, this location, this location, and this location. And we called that location at that time 4 meters to the left, for example, for this one, and 4 meters to the right. And then we called this here 5 meters to the left and 5 meters to the right. Why did we do that? Because we started our x from 0, so think of x moving positive in that direction. And because it's now our goal to actually graph these internal values and the values that we calculated in our last lecture, please go ahead and pull out your notes from lecture 13 and understand that the internal forces at the specific locations were determined in lecture 13. And so I have these values in front of me right now. You should do the same and pull up the notes, because we will refer to lecture 13, and that's how you will do it in the future as well. And please remember that what we calculated were the values for N, V, and M. So normal force, shear force, and a moment. And we did that at the specific locations of 4 meters to the left, at 4 meters to the right, at 5 meters to the left, and at 5 meters to the right. So we will use those values that we determined at these 4 locations to start our graphing efforts, and then I will show you how to extrapolate our knowledge that we gained from these 4 points to actually graph it for everywhere along the entire axis of the beam. And because we calculated 3 different force types here, or 2 forces and a bending moment, we now graph them on 3 different graphs that you can see prepared here for you. So we have 1 graph, 2 graphs, 3 graphs, and traditionally we usually put the normal force on the top and then the shear force and the bending moment. You could also put the shear force and then the bending moment and the normal force on the bottom. It doesn't really matter. What's important, and you will learn this today, is that there's always a relationship between the shear force and the bending moment. So to better see that relationship and to better utilize that relationship between the shear force and the bending moment, we always would put the shear force on top of the bending moment. So we could put the shear force here, the bending moment here, and then the normal force here. But again, traditionally, it's most common to put the normal force on the top. And because we want to use these values that we calculated here, 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 and here, I'm now first gonna bring down all my specific locations just so that I can better deal with them when I draw this. I don't always do this later, but for today, because it's the first time that we're doing this, please let's go ahead and faintly bring down these lines where something happens, as I usually say it. So I bring down all these lines, and in fact I even bring down the lines from the support reactions that will help me with better graphing.